In the previous part of this lecture, I showed you how to send real sensor data through the Helium network to the request bin. What we'll do now is to show the opposite direction of communication from the Helium network to the Arduino gadget with the atom Helium on it. In particular, what this communication involves is updating local variables on the Arduino. Let me explain what I mean by that. Let's go back to our application, and you can see that in the application that is running right now on the Arduino, the one that I showed you in the previous part of this lecture, we have defined a couple of variables, 32-bit variables. There's the send interval variable and the location ID variable. And in this case, I've set a couple of values as a default value for these two variables. So there's 5,000 milliseconds for send interval and just a number 1 for location ID. What I'd like to do is to be able to, over the air, change those values occasionally. So with the send interval, for example, let's say that I'm now happy with how the gadget is operating, and instead of doing an update of the sensor variables every 5 seconds, I'll be happy to just do this every 1 second, which, imagine that if you are using, say, 3G or 4G cellular data connection, could conserve you could conserve some bandwidth and lower the costs of communications. In the case of this environmental sensor gadget, it doesn't really need to update its values every 5 seconds. It's a bit too much. Within 10 minutes would be enough. So how can we change the update frequency without having to reprogram the Arduino? Which means, how can we update the value of send interval without having to reprogram the Arduino, bring it back to base and upload a new sketch? And we can do that by using the infrastructure that comes with the Helium network. So there we are. We've got configuration variables, and we can create as many as we like here. The idea is that the keys that we produce and we define here with the value can be transmitted to a specific atom just by filling this form here and clicking on the update config button. So let's have a look at how this works. First, of course, in the sketch, we need to create local variables, and they always need to be 32-bit integers, because that's how these configuration variables work. So 32-bit integers, we define the variables that we want to update, and we can give them a default value. Then we need to add the config object. So that's what I do in line 101. So we need to add the config class, I should say better, and create an object out of it, the config object. So what we are going to be doing then is that we'll be using this config object to first detect if a configuration variable has changed and therefore needs to be fetched over from the network and stored onto the Arduino. And if that is so, then the config object will help us to read the new values with the from the network and to confirm that they have been read. So that's the addition here in line 101. Going to scroll down into the setup function then, and there's a new line here, line 144, in which we call the update config function. I just scrolled through earlier, this one here, which takes care of the configuration update. We just pass a true so that no matter whether there is a new value or not in the configuration variables defined in the dashboard, the atom will still read whatever they are. You can call this function as often as you like. So here we are in the loop. I'm going to scroll down to the bottom of the loop. So you can see that here in line 235, again, I've got the same call to the update config function, but instead of saying true here, I'm just calling the isStale function of the config object. And this way, the update config code will only execute if there is a change in the configuration variables, otherwise it will not do anything there. So this means that we can update the configuration variables at any time during the operation of the Arduino, and not only when it's starting and it's going through the instructions in the setup method. So let's have a look inside update config. So going to update config right here. So what is happening in here is that once we go past this if statement, the first thing to do is to call the get function of the config object and ask for an updated value for the config interval underscore key. So have a look at that. That config interval underscore key is defined up here. And the contents of this key is this config.interval. Remember that that interval underscore ms is the key that I defined here. If I had defined another key like a test key, then you would need to also create a new definition here and call that something else, test config, I say, test config, and then prepend that with the config string with a dot then, and then followed by the name of the key as you specified that in the dashboard right there. Then give it a value, 1, 2, 3. I'm not going to do that now. And then once you do that, let's clean this up a bit. Once you do that, then you can call the get function of the config method as often as you like in order to find out the latest value as defined in the dashboard. And if this doesn't work, you can fall back to the default value that you can set in the third parameter, in this case 5000. Then we can report status. So report status is a function that comes with a library. I think you can go into the Helium Arduino repository, go into the source code, and I believe that is in here in the utils. There you go, report status. That's what it does. Make this a bit bigger. So report status, and you can look at the implementation in the CPP file, and report status just prints out some debug information like that. Back to our sketch. I'll do the same thing for the location key. So remember, I've got another variable that I want to be able to update called config location key, and the name of the key is location, which is what I have defined here in the configuration variables segment on the page. So I'll update the variable for that and store it in this local location underscore ID local variable. So this is a pointer, points to this memory location. So that's where the updated value for this key will be stored. And 1 is the fallback value. So if all that works out okay and the values have been updated, then what I do is inside this block, I call the set function. So the set function just reports back the contents of the sent interval and the location ID. So that will appear down here in the reported configuration. So you can see that because I'm calling location ID second, and actually sending the value of location ID second, what you see here in the table under reported configuration is the current value of that key. So since the sketch is already running on the Arduino, let's demonstrate what happens when I make a change to one of these config variables. I'm going to bring up the serial monitor first. Alright, so you can see that right now the variable is set to 5,500 milliseconds. This is the number that you see here going to change that to 5,000 milliseconds and click on Update Config. And let's have a look at what happens at the other end. A few seconds later, it's not totally instant, but it's very quick. That change will be picked up. And the number will change to 5,000 milliseconds. There you go. Fetching new configuration, updating configuration, 5,000 milliseconds. And now our LED blinks every 5,000 milliseconds instead of 5,500 milliseconds. And I can also change the location ID. Let's say that you decided to take this gadget from the current location and place it to a different location, and you wanted to now be able to transmit its new location ID to your application. You don't have to reprogram your Arduino to do that. You can simply pick the appropriate atom from your dashboard and change this to whichever new number you like to allocate to it as a location ID, and update this configuration. And this change will be picked up automatically by the atom, and your Arduino gadget will be reconfigured. There you go. Picked up the new configuration. Now it's still saying 5,000 milliseconds here because I haven't used the print command to show us the new location ID, but you can see it in the data that is coming through. The formerly location ID equals 1 is now location ID equals 2. You can see that in the CSV. We can also see that the value reported here in the reported configuration will be 2. I'm just going to refresh the page, and you can see that now it's become a number 2. What about the request bin? Let's get the latest from the request bin. And there's a number 2 reported for the location ID that we just changed. Great. So that's pretty cool, I think. Now, the last thing that I want to do for this series of lectures, or the last part of this lecture, is to show you how we can redirect this traffic from the request bin into a very simple web application that we wrote using Ruby and the Sinatra framework, which is running on the Heroku host. So I'm going to show you how to do that in the next part of this lecture. Thanks for watching. If you'd like to learn more, check out my Arduino Step-by-Step Getting Started and Arduino Step-by-Step Getting Serious courses on the Tech Explorations School. There, I help you develop basic and more advanced Arduino skills, including how to write your own programs, how to use all sorts of sensors and actuators, and how to create your own gadgets. You may also be interested in my project courses, where you get deep into the development of wheeled robots, remote-controlled cars, and drones. Please use the coupon code in the description below this video to get a YouTube exclusive discount to my courses. See you there.